Bismillahirrahmanirrahim. Assalamualaikum and very good evening to all of you. Welcome back to the class of Reinforced Concrete Design 1. In this video, we will discuss about the design of simply supported two-way slab. Okay, I hope you can see my screen now. From the module is from example 2.3, which is the two-way simply supported slab. I will adjust the data here, and then I will use this book to help me in terms of detailing. Okay, so let me start. Let us start. Okay, this is exercise number, wow, number apa ya? Exercise number 16. Okay, exercise number 16. I hope you are ready here. Okay, so the design of two-way slab is a bit quite similar to the one-way slab. However, the calculation is instead of secondary bar, if you still can remember that in one-way slab, we design the main reinforcement to the main direction. Main direction means that let's say this one. Okay, this is the main direction. Okay. I mean the bar number 1 is the main reinforcement, and then bar number 2 is the secondary. However, for simply supported two-way slab, both bar number 1 and number 2 is main reinforcement. Okay. And this is the way to determine the bending moment and shear force diagram. Bending moment and shear force for the simply supported one-way slab. However, for the simply supported two-way slab, we have to use the coefficient from the table. Okay, it's okay. I will show you later. Okay, from this example, okay, I want to change some parameters. Can you see my screen?
Yes, sir. Yes, doctor.
Okay, good. Thank you. Okay, so let us you can refer to your module. Okay, this is the shape, okay, the plan view and the cross section of the slab. Okay, so this is the parameter I just write down here to save our time. So exercise number 16. So in this exercise, the Ly is equal to 6,500 millimeter. The Lx, which is the shortest, okay, the shortest side is 4.4 meter, and then the permanent load without the safe weight is 1.5 kilonewton per meter square. This is without the safe weight. And then the QK is equal to 3.0 kilonewton per meter square. And then I give you the C nominal. It's okay. I will teach you on how to determine the C nominal in the last week or during the study week. The diameter is 12 mm. And then the FCK, I want to use the 30 Newton per millimeter square of concrete. FYK as usual is 500 Newton per millimeter square. And then the thickness of slab is given. Concrete density is equal to 25 kilonewton per meter cube. Okay, so let us start the solution. Okay, we will just the step is just like the design of simply supported slab, one way simply supported slab, as in exercise number 14, but different is about the how to determine the bending moment. That's all. Okay, and about the D and the detailing. Okay, so the solution is A is action and analysis. So the first action is slave weight of the slab. Okay, the exam, kalau in the exam, if you don't have time, you can use the short form like this one. It's okay lah, I can accept. HF times gamma of concrete equal to 0.15 times 25. So what is the answer?
3.75.
Okay, good. Kilonewton per meter square. And then the permanent action GK is given as 1.50 kilonewton per meter square. So total GK, you can write down like this one. Okay. Don't waste your time. So what is the permanent GK?
5.25.
Okay, good. 5.25 kilonewton per meter square. And then you have the variable action UK is equal to 3.0 kilonewton per meter square. Okay. And then so the design action and D is equal to 1.35 GK time plus 1.5 QK. So equal to 1.35 times 5.25 plus 1.5 times 3.0. What is the answer, please?
$11.59.
11.6 lah Okay, 6 kilonewton per meter square. So for every 1 meter, width and D is equal to sama lah 11.9 kilonewton. Now the unit is per meter. Okay, so simple. Okay, simple. Don't waste your time. And then next step is to determine. You have to determine the bending moment. So you have to determine the Ly over Lx is equal to your Ly is the longest section divided by 4.4 meters. So equal to
1.7.
1.7 kan? Okay, 1.47 less than 2.0. So this is 2 square slab. Okay, you use 1.5. Okay, you besarkan dia. Use 1.5. Okay, what is 1.5? 1.5 is you can refer to this slide, okay, of your slab design. Two-way simply supported slab. For simply supported, you can use this one, equation 10 and equation 11. Okay, this is equation 10 and then this is equation 11 to determine the value of bending moment. This is for the short span and this one for long span. Because okay, and sorry, then this is the coefficient alpha Sx, alpha Sy. So this is the table 3.13. So the ratio of Ly over Lx is here. So we got 1.47. So we select from 1.5. Okay, just select the nearest, the nearest. Because okay, okay, this is our slab. Okay, we have our slab. Okay, just neglect the, okay, for this one, we have to design, okay, let's say this is the Ly, okay, we have to design the 1 meter. Okay, let's say this is 1 meter here. For every 1 meter, yeah, okay, kita design for every 1 meter. This is for every 1 meter of X directions. This is our slab. that we are going to design. So we are going to design based on the bending moment. This is the, let's say this is the bending moment, M as X. Okay, this is X direction. X is always the shortest. Okay, M as X. Okay, and at the same time, because this is two-way slab, this is two-way slab. Okay, I hope you still can remember and not confused. Okay, this is a two-way slab. Okay, this is how the load will being transferred to the beam. Okay. Okay, this is how the load will be transferred to the beam, to the direction of to number 1, to number 2. It also will be transferred to number 3 and to number 4. So okay, this beam, okay, the slab, okay, this from this color, okay, let's say this is number 1 and this is to number 2. This is to transfer to number 1 and number 2. Okay, to transfer the slab, the load to number 1 and to number 2, and then to transfer the load to number 3, beam number 3 and beam number 4, we need this slab. Okay, we design for every 1 meter. It's okay. The location either at the edge or at the center, randomly, as long as it's 1 meter. Okay, so this is the slab. Okay, so the most critical is slab with light blue color or orange color, which is the most critical?
Orange.
Okay, thank you for your answer. But the loading will be mostly transferred to the orange, light, this one, to number 1 and to number 2. Okay, the percentage of loading will be transferred mostly to the number 1 and number 2. So the most critical is light blue color. Okay, always the shortest. Okay, always the shorter. Okay, and then so for this one, we need the bending moment here. This is the bending moment. Okay, this is M S Y. So if we can extract out, let's say this one. This is the light blue color of the beam. The slab. Okay, this is the support. The support is this, let's say number 1. This is number 1, beam number 1, and this is beam number 2. Okay, and the loading, and then this is support, and this is the length. The length is equal to what? The length is Lx. Okay, this is Lx. Okay, and then so this is why we need the moment. The moment here, M is the bending moment is M S X. Okay, and then for the orange color, the longer part, is like this one. Okay, let's say this is number 3, beam number 3 as a support. And beam number 4, this is beam, okay, this is beam. Beam at the bottom, okay, the slab is surrounded by beams at all 4 edges. Okay, this is beam. This is beam. Okay, beam. Okay, the green color is the beam. Okay, so this is okay, supported by beam number 3 and number 4, and then the length is equal to L what now? The length is equal to Ly. So here you extract out, then the bending moment is like this one. This is M SY. So you need, that's why you can see here you have 2 reinforcements, 01 and 02. Okay, we will detail it later. Okay, so you refer to this one. So the table, based on the table of table 3.3 for the coefficient, you can check your module or you can check your slide. Okay. I hope clear. If you not clear, then you can ask me, because the similar will applied to the two continuous two-way slab, which we will do the exercise about it by this class on Friday. By the class on Friday. So by table 3.13 alpha, okay, you write down alpha Sx is equal to 0.104 and alpha Sy is equal to 0.046. So the bending moment, okay, the moment, okay, the short direction, okay, for the short span, the bending moment is equal to this, okay, this equation. Can you see? Equation 10 and equation 11, this one, these equations. Bending moment for the short span, MSX is equal to alpha Sx times N times Lx square. So it's equal to 0.104 times our N is 11.6 times Lx is 4.4 square equal to
23.4.
okay, good, 23.4 kilonewton meter. So okay, this is okay. So here the mx here, the moment here is 23.4 kilonewton meter. Okay, just like this one, just like the simple supported. So this is the bending moment. Bending moment is equal to 23.4. Okay, and then you can do the design. Okay, so about the how about the long span? Long span. Okay, you refer to the equation M Sy is equal to alpha Sy times L times Lx. Always use Lx. Okay, don't confuse. So equal to 0.046 times 11.6 times 4.4 square. Okay, any answer?
10.3.
Okay, thank you. 10.3 kilonewton meter. Okay, so we finished the analysis part. Now we can do the part number 2, part B, which is the design of main reinforcement. So the first of all, you have to determine the depth. Okay, the effective depth. Okay, D1 and D2. So okay, this is also important class, D1 and D2. So because D2 always the bottom, okay, this one is very important. Okay, at the bottom one, okay, can you see this one? As I mentioned before, we have two direction of slabs, okay, the shorter and the longest. So the D1 is this one, okay. This D1 is, okay, let's say, be careful, okay, this is D1. Okay, this is the, here to here is HF. So D1 is from this HF. Okay, from the D1 is the orange color here to this here, bottom reinforcement. Yes, to the dot. This is D1, DX, okay, because this slab, the reinforcement number 1 is for short direction, okay, which is X direction. So, and then the DY is here, up to the center of this bar. This is DY, okay. So, be careful about this one, DY and DX. Okay, like this one. So I hope I can enlarge this so you can see clearly. So let's say this is your slab. Okay, the cross section. So this is the reinforcement for x direction, which is the shorter. Okay, we put it at the bottom. Okay, at the bottom. Sometimes in the drawing there will BB bottom, and then BT is bottom top. Okay, so this is the reinforcement. Okay, the reinforcement should be like this one. Okay, the green color. Okay, the reinforcement. Okay, sorry. Okay, this one the reinforcement. Okay, like that. This is the reinforcement letter. They will arrange. Okay, what is the size of reinforcement and what is the spacing? This is the reinforcement. So this is the green color here. Okay. I hope you can see. Okay, because here to here is your C nominal. So your D is equal to like this one lah, ya, orange color ni kan. Okay, this one. This is 4. This is your dx. Okay, and then let me use the blue color. Okay. Okay, this is another bar on the top. Okay, it's the blue color. Sorry, okay, let's say this is the diameter of the bar. Okay, so this is bar number 2, 02. And then this is the bar number 1, 01. Okay, and then so the color is okay because the blue. Okay, so this is the the reinforcement letter will be like a different color. Sorry, so because of Word and PDF. So this is the reinforcement letter. Okay, for MSY. So we put it, since I mentioned before, the most critical is the shorter direction, which is MSX. Okay, so we put it here because we want extra D. Extra D means extra Z. Z, okay, you can see the equation letter. So this is the, sorry, this is the, up to the center here is the dy. Okay, I hope you understand what I'm trying to show you, what I explained. Okay, and then so the dx is equal to, anybody know the equation? Oh, sorry. So the dx is equal to hf minus c nominal minus diameter of bar. Okay. So equal to 150 minus 30 minus 12/2. Any answer, please?
114 mm.
Okay, 114 mm. Okay, and then the dy is equal to hf minus c nominal. Sorry, this is over 2. Minus diameter of bar, and then because this one, you have to minus diameter of bar of this, and then another half for the blue color. Bar over 2 equal to 150 minus 30 minus 12/2 equal to 102 mm. Okay, so clear. So the second step is you check the AS minimum and AS maximum as usual. Okay, this one it's okay. Let's do it together. As minimum is equal to 0.26 FCTM B times D divided by F YK greater than less equal to 0.013 BD to 0.26 FCTM equal to
2.9.
2.9.
okay 2.9. Okay, 2.9 because the concrete grade is 30. So our D, we always use the largest D. Okay, use the largest. Use the larger one. This one. 114. Okay. 114 divide by 500. Okay. Create a larger to 0.013 1000 times 114. Okay, any answer? For this one?
172.
172 mm square. This one? 148. Kan? Square. Okay, so you use AS minimum is equal to 172 mm square. So you must provide the reinforcement must be larger than 172. So AS maximum is equal to 0.04, AC equal to 0.04, B times HF equal to 0.04 times 1000 times 150. Any answer? Answer is
6,000.
okay, good. 6,000 mm square. Okay. And then the number 3 is we design for the short span. Short span at mid span. Okay. We never design for at the support because the shape of the bending moment is like this one. Bending moment is this one. So the tension is at the bottom. So we only design for the reinforcement at the bottom. So this is the detailing. We just use this one. Okay, mid span, our M SX is equal to 23.4 kilonewton meter. So our K is equal to M by FCK dot D square. 23.4 times 10 to the power of 6 divided by 30 times 1000 times 114 square. Okay, help me.
0.060.
0.06 lesser than 1.67. So this is singly reinforced. So our Z is equal to D 0.5 plus 0.25 minus. You can use this one. Okay, you don't have to write down the equation for this one. It's okay. 0.6 divided by 1.134. Okay, don't waste your time. So what is the answer? Zero point nine.
Zero 0.94.
Okay, 0.94 D lesser than 0.95 D. So you choose the lesser. So AS required is equal to M over 0.87 FYK dot Z is equal to 23.4 times 10 to the power of 6 divided by 0.87 times 500 times 0.894 times 114. Be careful because you are doing the short spans. So this is a dx actually. Okay, dx. Okay, this one also dx is 114. Okay, so the answer 5. Okay, 502 millimeter square per meter. So you provide Okay, you refer the table. Okay. Okay, select from the H12. So you can, which one to select? Which distance? Focus only on bar diameter size 12 mm. Okay, any spacing to propose?
Hashtag 225.
225, okay. 200, okay, 200 also okay, 225 also okay. Because it's larger than the required. So I want 225, okay. Okay, let's say provide H10, H12, 225. Because this is the most economic. Kadang-kadang soalan you kena, in the question you must alert the most economic. When I ask the most economic, so you must select just a bit higher than the required. Okay, as provided is equal to 503 mm2 per m. Okay, or maybe if it failed the deflection, you can increase. Okay, so this one, okay, so H12225. So let's take a look on the dimension. So this is the detailing. Okay, green green color. Green color here is, so this one. So this is the how to do detailing. So the shortest, okay, this is they will put the in this direction. They will put in this direction, and then you mark with your arrow here. Okay, means along this arrow line is reinforcement number 01. Okay, here 01. You number the reinforcement, and then the reinforcement here now is H12225. Okay, sometimes they will just do it here. H12225 BB means bottom. Okay, so this is the reinforcement. If you cut the cross section, okay, this is the cross section. Okay, let's say XX. Okay, the cross section here is here. This is the reinforcement. Okay, the green color here. Okay, be careful lah. Once you are maybe one day got intern for contractor, you check. Okay, what is BB? BB is this one. Bottom. This is bottom and bottom again. Okay. Okay, and then then you calculate for the number four. Okay, long span. For the long span, MSY is equal to berapa ya? 10.3 kilonewton meter. So calculate for me the value of K equal to, saya tak payah buat equation lah ya. 6 divide by 30 times 1000 plus, okay, this one you be careful, the D is this one. D is, you select the 1 or 2. Please don't make the silly mistake. So D, the long span is belong to the dy. Okay, 102 square. So what is the answer? 0.0.
0.033.
Okay, good. So lesser than 0.167. So this is also singly reinforced. So you as usual, just determine your D. 0.5 plus square root of 0.25 minus, just insert the value directly. 1.134 equal to 0.9 something, and then you use 0.95D. Ni 0.9 berapa ni?
97.
Okay, good. 0.97D. Okay. Clear? So this one. Okay, and then the AS required is equal to M over 0.87 FYKZ equal to 10.3 and 5 times 102. Please don't do the mistake here. And then what is the answer? Any answer?
Two four four.
Okay, 244 millimeter square per meter. So which one to provide? From this table, you get up to 300, but 300 is still large. Okay, 377. Okay, why not we try to go for maximum? Because this is not secondary bar. This is not the secondary bar, so the maximum is 400. Okay, let's say use the formula that yang saya ajar tu. Okay, so the AS is equal to, for 1 is equal to this one, 113 for 12, 113 mm square. So 1000 divided by 400 times 113 equal to 283 kan? Dapat tak? Okay, recall back. Okay, what I teach you about this one. Okay, 283 millimeter square per meter, and this one is still larger than the S minimum. This is our S minimum 172. So we have larger than S minimum, and still the maximum is 400 because this is not the secondary bar. Okay, you can check this one later. Okay, later I will show you. So the dimension here is 400. Okay, so you provide H12 400 mm center to center. So this one AS provided is equal to this one. Okay, so the detailing is this one. Detailing is let's say the blue color. So this is the reinforcement you calculate. Okay, dia melintang ke arah situ. So dia macam ni atas. This is okay. Here and here. Okay, number 02. Sometimes they will label as, okay, so they will label here at this note as a note. So H12 400. So sometimes they will write down here H12 400 BT, bottom but top. Okay, this one is BB. Okay, bottom, and then this BT, bottom but at the top. Okay. Okay, so then next step is you check for. Okay, I think I leave the task here for you. So you finish this exercise, and then you submit as attendance. Okay. So step number C is you check for the shear reinforcement, and then D you check for deflection, and then E you check for crack. Okay, it's okay. We will tackle one by one. So here the shear is this one. Okay, to determine the value of shear force, you can directly use this equation LS/2. Okay, because the shear force is like this one. Okay, so you just use the maximum. Maximum, of course, go to the LX. Okay, LX/2. Okay, so kalau dia pergi yang ni macam mana ya? 4.4, 4.6 lagi besar kan? Kalau if you go, you check for VED is equal to NLY over 2. Okay, it will become larger, right? So you better check for the largest actually. Okay, you check for the largest and the D is equal to D yang largest lah. Okay, for direction number 2, this one. Okay, direction number 2, the orange one. This one will produce largest shear force. Okay, because the Ly is greater. Okay, so you check. Okay, this one I want you to try by your own. Okay, you use the Ly. You try to use the Ly, and then what is the value here? And then the D is this one is dy. Okay, this is also dy, and then also dy, and then you compare to the VDRC, and then the V minimum, and make sure that this is greater than the VED. Okay, then it's okay. And then you check for the deflection. As usual, you use do this exercise. Okay, for the deflection is very important. Okay, I hope you know as required. Okay, the deflection you check for the X direction. Okay, for the shortest direction, because this is the most critical. Okay, so you check for the LX. Okay, check for the LX, and then make sure you use the D is the D here is the DX. Okay, 114 tadi. Okay, 114. And then after check the deflection, you can check for cracking. So make sure the maximum, okay, the spacing is 3H. Okay, 3H. Okay, make sure it's less than 400. 400 is maximum. If secondary bar, let's say this one. If it's the secondary bar, the maximum is 450, like this one. Okay. Checking this one for secondary bar, maximum is 450. However, once you are dealing with the simply supported two-way slab, there is no secondary bar. Okay, both direction is main reinforcement. So you check the spacing must be lesser than 400. Okay. So I hope you can try this. You can finish our exercise up to cracking. Okay, up to cracking. You can finish up to cracking later. Any question, class? Okay, if no questions, thank you very much for your attentions. See you again later.